Hi, this is Mr. Manley, and this is a video on solving systems of inequalities. I'm going to jump right in here. The first thing that I want to tell you to do when you're solving a system of inequalities is use graph paper. You really have to. Second thing is I want to number each of the inequalities that I'm given. And this is something that I also really think that you have to do. Now I want to graph each of these inequalities as if they were equalities. And that's going to give me the edge of the solution for that inequality. So for the way that I'm going to do it is I'm going to go with the first one. I'm look at number one here, and I'm going to let x equals 0. So if I let x equal 0, x zeroes out, right? And then I have negative 7y. And remember, I'm thinking about this as an equality. I'm not worrying about the inequality aspect of this. And then from there I can see that y is equal to 6, right? Or not 6, it's equal to 36 over 7. 36 over 7. And then I'm always going to go ahead and let y equal 0. So this is the way I'm going to proceed. I'm going to let x equal 0, then I'm going to let y equal 0. So if I let y equal 0, that zeroes out. And I get x is negative 36. Now I'm thinking, well, I'll just hold off. So I got my x and y intercept for that inequality. And the edge of the inequality is its equation. So again, I'm just thinking about if it were an equality, what would I have? Okay, so let's move on to the next one. And the next one, if I let x equal 0, and I zero out x, then I'm going to have y is equal to 5 halves. And if I let y equal 0, I'm going to have x is equal to 1. And then moving on to the third inequality, x is 0, y is negative 6 over 5, y is 0, x is equal to 1. Then I'm going to want to graph each of these. So I'm going to go over here and set up an xy axis. Now, before I get too far into this, I want to look at my x coordinates. I have a negative 36, a 1, and a 1. That's not going to be really convenient for my scale. Do you understand that? If I like, just say I want to do a scale of 1, and I want to call that 1, well, that's going to put negative 36 like way out here somewhere. That's not going to be very convenient. So because of that, I'm going to go ahead. Now I know in the beginning I say, well, I'm letting x equals 0 and solving for y, and I'm letting y equals 0 and solving, and that's how I'm always going to proceed initially. And a lot of times that works out. But in this case, I've actually got this point here. This negative 36, 0 is just not a convenient point. So I'm going to cross it out, because I don't really want to use that. And I'm going to think about a different point that is going to be more convenient to graph. So when I look at this, what's jumping out at me, and you can do this however you want, but what jumps out at me is if I let y equal 5, then what am I going to have? I'm going to have x minus 7 times 5. Remember, I'm thinking about it as if it's an equality. And then I'm going to go plus 35, plus 35. So x is going to be equal to negative 1. That's a more convenient point. Negative 1, 5. Okay? And then when I look at the y coordinates that I have, like here, that y coordinate is at 5 and a seventh. And then I've got 5, 2 and a half, negative 1 and a fifth. Those are all convenient if you can understand that. Okay, so let's go ahead. I could probably just use a scale of 1. If you look at the graph now, I could do a scale of 1 like that. But 1, 2, 3, 4, x. I'm gonna try and do it like this. 1, 2, 3, 4. No, I'm just going to stick with the 1. Okay, so we'll do that as 1. And then what about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I guess I'll keep that at 1 also. I just don't know how much space I'm gonna want. So I'm gonna do 1 and 1. And then we'll go ahead and graph. So I'm going to graph the first one here, and that'll be graphing this point, 0, 36 over 7, which is 5 and a seventh, right? So 1, 2, 3, 4, 5 and a seventh. So I have a point there, and I've got point negative 1, 5. So I'll have a point there. Just a comment, when you're doing these graphs, we would like them to give us the information as clearly as possible. And when you have points that are close together, that makes it less possible, or it doesn't give us as good of a graph necessarily. It's not necessarily going to be bad, but if I had my preference, I would have 2 points that were farther apart. Maybe I'll explain that at some point, but maybe you understand why anyway. So there is my edge for this inequality. That is the edge, treating it, just looking at the inequality as if it were an equality, I get the edge. And then I need to put in a few more things here. One is I'm going to number it. So look in the upper right there, and I'm going to be very clear that this edge represents the inequality number 1. And then the second thing I'm going to do is notice that it's greater than, and I want to look for, is it like if it were greater than or equal to, I would leave that as a solid line. But since it's a greater than symbol, I'm going to dash this line. And I'm going to have to use a smaller eraser than that. Okay, now I should be able to dash it. There. And then finally, I want to know what region to shade. So the solution is either everything on this side of the edge, or it is everything on this side of the edge. And that would continue all the way down here, everywhere. So I want to figure that out by looking at look at the origin, and if the origin is part of the solution, then everything on this side is part of the solution. If the origin is not part of the solution, then nothing on this side is part of the solution. So make sure you follow that couple of statements that I made. Okay, so if I take this origin and I plug it in for x and y here, that zeroes out x, it zeroes out y, and then the question is 0 greater than negative 36? The answer is yes. So the origin is part of the solution set, and that means that everything on this side is part of the solution set. And here's the way that I prefer to indicate that. I prefer not to do the shading. What I like to do is just do some arrows here and say, okay, the solution is over here. And just do a series of arrows coming off that edge. All right, and then we're going to do that for all of the inequalities. So for the second one, makes it a little bit easier on me since I have different colors maybe, but Okay, 0 to 5 halves, so that's 0, 2.5, and then 1, 0 there. And I can see again that this is greater than, it's not greater than or equal to, so I'm going to do a dashed line through those points. I'm going to label it 2. And I'm going to see if the origin, so here I'm going to look at the origin, I'm going to plug it in here, that zeroes out, that zeroes out, when I plug in a 0 for x and a 0 for y, and then is 0 greater than 5? No, 0 is not greater than 5, so the origin and everything on this side of the edge is not part of the solution set. So my solution set is going to be everything over here. Again, I'm not gonna show it like that. What I am going to do is I'm going to do these arrows, so the arrows are all coming off this way, but I'm not going to do any arrows up here because that's kind of pointless. I guess I'll just leave them there, but I don't need those arrows because I'm only looking for the places where the arrows overlap. So at this point, I've got the arrows overlapping in this region here. And that's where our solution is, right? Okay, so let's go back and do the third inequality. And for the third inequality, I have got, let's try green. I've got 0, negative 1 1/5. So I've got a point down here. I've got 1, 0. And then I've got that edge going through here. All right, I'm going to number that, number 3. And looking at the origin and plugging that in here, 0, 0, is 0 greater than 6? No, it is not. So I'm going to do my shading away from the origin this way, here. And now you have to look and see, can you tell where all of the arrows are converging? So take a moment and do that. And then I will show you all of the arrows are converging here in this region. And probably, so if you were using a pencil or a pen to shade this, you would just have to kind of shade that. Maybe wouldn't do as good a job as me. Maybe you take out a highlighter and do it, whatever. Okay, now we're not done. There is going to be an additional instruction to label the vertices, and that it means the corners. And another thing that I say about the vertices is that the vertices are the corners. Label the corners of the solution set. So that is, I have to label this and I have to label this. Now, I'm going to do it in two ways. One is I'm going to label them with letters. So I'm going to call that A and I'm going to call that B. That's just an arbitrary choice. And then the second thing that I'm going to do is I want to find the actual coordinates. What are the actual X, what are the actual X, Y coordinates of those vertices or those corners? And that's a simple system of equations, right? Because I just want to know where does this edge intersect with this edge? So I'm going to find do the system of equalities to find where those intersect. And then of course for the other one I'll do this edge and find where do those two intersect. That one's actually really easy, right? If you look at A, And let's say I'm going to find A at, let me bring this down a little bit, at, what's the, look at, and that's another reason why I label these, right? So I label these so it's really easy for me to see, okay, which two edges intersect there. So I'm going to say A at 2 and 3. Well, in this case, there's no solving necessary, right? Because look at the XY chart, the XY table here, 1, 0, 1, 0. That's where that point's at. It's at 1, 0. So there's no work required here. I can just see that it's at 1, 0. So let's say A at 2 and 3 is 1, 0. So there's my first vertice that I've labeled. And then the second one is B at, and look at what's intersecting up there is 1 and 3 are intersecting. And so we want the XY coordinates where those intersect. And I'm gonna, so if we look at 1 and 3, if I look at 1 and I look at 3 and I think about those as equalities, right? Because looking at them as equalities is going to tell us where those edges intersect. If I look at that, then I'm going to say, to solve that system, I'm going to say x is equal to 7y minus 36. So do you see I took that first inequality there, I called it an equality, and then I solved for x. And then I can substitute that, so I can take and substitute for x in number 3 here. Okay, so I'm solving by substitution is what I'm doing. All right, so let's do that substitution. So I have 6 times 7y minus 36, which is minus 5y equal to 6. Okay, and if I go and solve that, I'm not going to work through all the steps on it. This is just basic algebra, right? So if I work through it, and I'll just keep going on that line, I find out that y is equal to 6. And then, of course, what do I do with that 6? I take that 6 and I substitute it back in for y. In either one of these, in that one or in that one, it doesn't matter which one. I substitute it for the y to solve for x. So that if I substitute it into the first equation, that would be, so I'm going to go ahead and label that I'm finding x here, and I'm going to have x minus 7 times 6 is equal to negative 36, and when I solve that, I get x equals 6. So I've got y and I've got x. That's the place where they intersect. So we'll write that in. And that's what I need to do to answer this part of the question, to label the vertices. Now I've got them. If you look over at the graph, I know that this vertex is at 1, 0, and this vertex is at 6, 6. Okay, and look at that. Okay. Remember at the beginning I said I didn't like having these points so close together because that wasn't going to give me the most accurate graph, and we can see that bears out because this point up here, that's definitely not 0.66. And what happened is that this graph here, I should have had a different trajectory on that. I was more like this point here, that point there. I did it more at like 5.5 than 5 1/7, and that made a big difference. So this should have come in more like this. So that should have come in more at that angle there, and then I would have got would look like the intersection is at 0.66. So that's that's not gonna affect the assessment of work, but it is something just something to be aware of, that if you do that, then you're going to be saying, hey, my answer doesn't make sense. But then if you look and go, and I want you to be able to look and say, well, the reason that the graph is off is because my points are too close together, and if I fix that up, then it would look better. Okay, so that is solving systems of inequalities. And if you have any questions, I hope if you're in my class, you will post to the Canvas discussion board.